All right, good evening. Welcome back to pre-calculus. We are going to be doing another logarithmic equation. So let's go ahead and jump right into this one. Okay, so again, as we talked about last time, um, we want to take the anti-log of both sides, but I want a clean anti-log. I don't want it to try to distribute an anti-log between different terms. Like that's not how logarithms work. I don't really want to deal with anti-logs in that same way. So what I'm going to do is I'm going to pile up everything on the left-hand side into one logarithm so that I can take one anti-log on both sides and be able to solve the equation. Now, we talked about this last time, but one of the rules of logarithms that we like to use is the log of AB is equal to the log of A plus the log of B. Okay, this is not to say that the log of A plus B is equal to the log of A plus the log of B. That will get you a really unhappy grade. You won't like what you see after that. I won't like what I see either, but you will be more unhappy than I will. Okay. So what we're going to do is we're going to use this equation. We're going to use this little identity here backwards. Okay. So what that's going to do is say that we have log base 5 of 3x minus 5 times 2x minus 5, and that's equal to 3. I like to put little brackets around this to keep everything in its own boxes. And there we go. So what we have to do next is we have to distribute this stuff. So we have log base 5 of, here we go, 3x times 2x. That gives us a 6x squared. We're going to have a minus 3 times 5 minus 15x minus, it looks like 10 x's, 5 times 2. And then we have a plus 25, negative 5 times negative 5. That is equal to 3. Okay, so here we go. Now, let's go ahead and combine our terms. So we have log base 5 of, we have a 6x squared minus 15 minus 10. That's going to give me minus 25x's plus 25. Okay, and then that's equal to 3. Now it is time for the moment of truth. Now we are going to unlogify both sides or take the anti-log of both sides. We're going to make both sides the same base. What base am I going to use? I'm going to use base 5 because that's what base my logarithm is in. Okay, so we make this whole thing the exponent to a base of 5. We're going to make this right-hand side the exponent to a base of 5. Be careful on how you write it. Don't just cancel out the logs. You have to go ahead and write it so I can see what you're doing. This is what you're trying to do. So this piece pretty much cancels the logs. Remember, logs undo exponents, exponents undo logs. So we have a 6x squared minus 25x plus 25, and that's equal to, this is not 5 times 3, this is 5 raised to the third power. That's 125. Okay, now we can go ahead and finish solving this thing. So we have 6x squared minus 25x plus 25. We're going to subtract 125 from both sides and say that's equal to 0. So here we have 6x squared minus 25x. 25 minus 125, that's minus 100. And that's equal to 0. Okay, so at this point, we have to do a C method. We're going to say 6 times 100. That's going to be 600 negative. So I need a difference that's going to add up to negative 25. And then we would just go through and make a little, we'll just do a factorization into the primes. Fundamental theorem of arithmetic lets us do that. That's what fundamental theorem of arithmetic says, is you can take a composite number, break it down to its base primes. There you go. So it's going to be 1 and 600. We have 2 and 300. We have 3 and 200. I know this is a little bit tedious. If you see one that works, you can jump forward with it. That's fine. Okay. Let's see. We have 4. This is 6 times 100. If I say this is 6 times 4 times 25, I pull the 4 out of there, 6 times 25. What is that going to do for me? I think that's a buck 50, right? 4 quarters or 6 quarters rather. It's $1.50. 5. I don't know what 650 divided by 5 is. So let's see what that's going to do for me. We have 6 times 20 times 5. I'm just trying to divide this out. If you said got your calculator and said 600 divided by 5, that's fine. But it's 5 times 120. Okay. 6 times 100, I can do that one. Okay. I don't think 7 goes in there. I don't think well, 8 goes in there. Okay, but I don't know what 8 times what is equal to 600 off the top of my head. I might cheat here. It's like, okay, what's 600 divided by 8? Okay, divided by 8, 75. Okay, there we go. 9 doesn't go into that. No. And 10 and 60. And we could keep going with this. What I'm doing though is I know that the signs are different, so there's going to be one that's plus and one that's minus. So I'm looking for a difference to be 25. Okay, that's kind of what we're dealing with here. We're getting kind of close to what we're looking for, but I think we still got more to go, don't we? Yeah, we sure do. 11 is going to do it. How about 12? Let's see if 600 divided by 12 is something. I think it is, but let's go ahead and divide by 12. Um, okay, 12 and 50. 13, 14, 15. Let's see, 600 divided by 15. Okay, divided by 15. And that is going to be 40. So we have 15 and 40. I don't think 16 is going to go in there, but we could check, but I don't think it's going to work. Okay. Yeah, that didn't work out so well. 17 doesn't. 18, I don't think does, but let's check. 18 divided by 600 divided by 18. Nope. No, 600 divided by 18. That was ridiculous. 600 divided by 18. Make sure we use the right units in the right operation. No, that didn't work. How about 20? 600 divided by 20. I'm being lazy. I think that's going to be, I think it's going to be 30, but 600 divided by 20 is going to give me, okay, it's going to be 30 like I thought. Okay, so we have 20 and 30. How about 25? And I know that that goes into it. If we can try 21, 22, that's going to work. 23, 24 is not going to go, so let's go with 25. So we have 600 divided by 25, 24. So we have 24, 25 and 24. 25 and 24. All right, now we're getting kind of close to the idea here, and we are looking for 25. What's 40 minus 15? Is that a good one? So 40 minus 15, that's 25. Go figure. That might be the one to go with. 40 and 15. I think that's the one to pick. So we're going to say this is going to be 6x squared minus 40x's plus 25x minus 100 equals 0. So this negative 25 is really negative 40 plus 25. That's what we're doing. Now we can pull these apart as factoring by grouping. It looks like there's, 3 doesn't go into 40, so it looks like we're going to have a 2. Yeah, so we have a 2x here. And what's left? So we have a 3x minus 20, okay? And then plus, and then I think we can pull out a whole 25 here. Mhm. Well, that's going to be x minus 4. That's not working out. Hmm. Let's see here. What did I do that's not going to work out? Okay. Well, negative 40 plus 15 is going to give me the negative 25. I'm looking around for other things that were going to be kind of close to that. And I'm not seeing an easy way to go and get a 5 out of here. Um, hmm. Nope, that's about it as far as that goes. Let's see here. Did I do this correctly? Okay, that's what it is. I messed up right here because it's 20, it's 40. Is it 40 and 25? I don't think it is. It's 40 and 15. That's what it is. Aha. So that's where I messed up. It's right here. It's 40 and 15. Okay. There we go. So that's going to mess all of this up. Okay. So let's see. We'll go back up to here. I'm sorry about this. So we have minus 15x, okay, minus 100. So we have minus 15x minus 100. Let's go ahead and do it that way. So we have 2x. I pulled a 3x minus 20 out of here, minus, let's pull a 5 out. So we have a 5. I pulled a negative 5, so that's going to change my sign. That's going to be 3x. And then 100 divided by 5 is going to be 20. And because I'm doing both of these, is this 100? It is, oh, it's plus 15. Okay, so it's not that. Okay, so we pulled the plus out. So we have plus 5, and then we have a 3x. I pulled a plus out. So we pulled a plus out of there. That's going to be minus, and then that's going to be 20 here. There we go. All right, now that we've factored, all right, we're going to go ahead and say this is a 3x minus 20, and we have a 2x plus 5 equals 0. At that point, we can say zero factor principle, 3x minus 20 equals 0, 2x plus 5 equals 0. We have 3x equals 20, or x equals 20 thirds. Here we have 2x equals negative 5, or x equals negative 5 halves. We have to check these answers. Okay, so we are not done yet. We have to go back up and check the answers to see if it actually works. You go back up to the original statement of the problem, and we're going to plug these answers in. And then I can tell you that by inspection, this negative 5 halves, if I plug in negative 5 halves into either of, where are we? No, we're in here. If I plug in a negative number into either of these, we get a negative number, we get a negative number. That means that's not a solution because they get extraneous. Okay, that doesn't work. So it's an extraneous solution. That's not a true solution. So we only have one solution, which is x is equal to 20 thirds. And we are happy about that because that's going to give me positive numbers. We do have to check them both. It'd be nice if we did that. So if I go all the way back up here and I plug in my 20 thirds, kind of doing this by inspection to say 3 divided by 3 times 20 thirds is going to be about 20. 20 minus 5 is positive. 2 times 20 thirds is going to be 40 thirds. 40 thirds minus 5, that's also going to be positive. So by inspection, we've made sure that this actually works. We've made sure that that works. And there we go with our happy answer. All right. Thank you very much for tolerating that kind of a problem, but good luck with everything. And thank you for watching. And I'll see you in the next one.